This is an exciting time because geoscientists have never had access to more and different types of digital geoscience data. But this presents a challenge for working with it, especially in a business setting where machine learning algorithms and advanced analysis techniques need to access this data in a repeatable way. So all of this data comes in a wide variety of different data formats, different types, and often this data is located in different places throughout an organization. It might be in different software applications or even be in PowerPoint folders and so on. So a big challenge is developing a system that can reproducibly import this data and create a consistent data set that can be used by geoscientists and algorithms alike. We've created a number of data processing pipelines that automate the process of cleaning and storing these data types. We have DLIS readers that can convert well-bore image data into convenient numerical file formats, such as HDF5. LAS file readers that can automatically determine bad data regions and do alignment. Core photographs are often provided in box file format, and we can automatically extract those and visualize those in depth along with the rest of the data. Data cleanup is an important step and often takes a lot of time if manual processes are used. To illustrate this point, I'm going to talk a little bit more about CT data, which is in a raw data format that's notoriously difficult to work with. DICOM files were originally designed for the medical industry, and one slice of this data is taken for every 0.3 millimeters or so of core in a whole core CT scan. So the first step we do is combine these hundreds of thousands of files into a single scientific data format that's convenient to work with. And then often a significant amount of cleanup needs to be done to further prepare this data. When core is extracted, it can be encased in different material when it's put in the CT scanner. Some sections could be encased in aluminum, some sections in wax, and this causes an apparent offset in the CT number that gets detected. And we normalize this data between sections so that a rock type that's encased in one material looks the same as the rock type in another. We also remove artifacts from this data set. We remove the tubing, mud residue, any fracture void space that might be there. We can also correct for things like beam hardening and so on, which is an apparent lightening of this material towards the outside of the core. So all of this data that we're importing is associated with its own depth scale. Well log comes up from an operator measured from a certain depth datum. Core CT scans get extracted and their depth range is recorded. But as this data gets handled and cut and core photographs taken, there can be shifts between the data sets. There can be discrepancies between data provided from different vendors and so on. And so we've created tools that allow all of these different data types to be aligned in depth so that when we extract features from a certain depth, we can be sure we're getting a consistent set of features across all of the data types that we have available. In addition to aligning the data in depth, it's also possible to use well-bore images and CT data to rotationally align the core. This is useful for studying the in situ direct alignment of fractures and also for paleo current direction and so on. One of the main challenges in working with all of this geoscience data is knowing where to find it. Typically, geoscience data is scattered across the hard drives throughout an organization, oftentimes in PowerPoint files and Excel spreadsheets and so on. Also, different geoscience workflows typically silo the data in their own place. Virtual Core integrates all of this data and provides a centralized, searchable storage with a very convenient API that makes it straightforward for both machine learning algorithms and scientists to use this data in a very robust and reproducible way. It's often said that data cleanup and preparation can take up to 80% of the time in data-intensive workflows. And this is certainly the case with geoscience data. Virtual Core provides many of the tools to automate this process, removing the amount of tedious time and effort that's required by the geoscientist to prepare the data, allowing them to focus more on the analysis and scientific interpretation.